In this video, I'm going to be taking a look at a difficult buoyant force problem. We have a 350 gram hollow cylinder that's 15 centimeters tall that has 10 centimeters of it submerged in water. How much mercury is required to make the cylinder become completely submerged? We're looking for some kind of volume in milliliters. So we have a cylinder that is partially submerged in water. So we have a container, it's filled with water, and we have some of it that is submerged. Let's see, we have 10 centimeters of it submerged, and it has a total height of 15 centimeters, so an additional 5 centimeters up here. All right, so let's go ahead and start off with some forces. We have the force of gravity, which is basically the weight of the cylinder. And then we also have the buoyant force pushing upwards, which is equal to the weight of the water that's displaced. That is our initial scenario. And then as soon as we add some mercury in there, then we're going to have an additional force downwards from the mercury. And we have Hg, our symbol for mercury, and then I'll put CYL for the FG of the cylinder. All right, so initially we have the buoyant force that's equivalent to the force of gravity of just the cylinder because it's in static equilibrium. Now, at this particular moment, we can say that we have rho Vg equal to mg. The g's are going to drop out. We have the rho of water, which is our constant, 1,000 kilograms per meter cubed, as shown up here. And we have a volume that we don't know as of now. And then that's equal to the mass of the cylinder. It says 350 grams. Let me go ahead and divide that by 1,000 and make it 0.35 kilograms. Now, I can't really go too much farther. So what I'll do is I'll do a little substitution and substitute in the area times the height for our volume. And then now we have 1,000 times the area and then times our height. Our height that's submerged is 10 centimeters. So I'm going to go ahead and divide that by 100 and call that 0.1 meters, so that we're all in our standard units of kilograms and meters. Now from there, let's go ahead and set that up over here. 1,000 times 0.1 is 100. So 100 times A equals 0.35. Divide both sides by 100. And that gives us our area of 0.0035 meters squared. Now, we weren't looking for area for our answer, but that will probably be some useful information later down the line. So let's go ahead and add that up here into our list of known variables. And then clear some space and see if we can find a solution that will help us find the volume of mercury. Now for the second part of our problem, we are going to have this cylinder become completely submerged. So we still have a buoyant force down, but we're combining our two FGs, our FG for the mercury and then our FG for the cylinder as well. So we're still going to have rho Vg equals mg of the mercury plus mg of the cylinder. And then our g's are going to drop out. And then we have the mass of the mercury, Hg, plus the mass of our cylinder, which we do know. We called that 0.35 kilograms earlier, and it still is. And then over here, we have rho of 1,000 still, times our volume. And we didn't have our volume previously, but we do know volume is area 0.0035 times the height. Now the height is now the full 15 centimeters, now that we're saying that this is the portion of the problem where it's becoming submerged. So 15 divided by 100 is 0.15 meters. So when we finish working this out, we get 0.525 equals the mass of mercury plus 0.35 kilograms, the mass of the cylinder. And then we're going to subtract this. And then we have a mass of mercury, which is 0.175 kilograms. All right, so that looks like a helpful piece of information, although that's not our final answer, because we're looking for a final answer that is a volume in milliliters. So we do know that if we take the density of an object, the density is the mass over the volume. Therefore, the mass is equal to the density times the volume. So that's exactly what we're going to use. We have a mass of the mercury. We know the density of the mercury, 13,600, as given by this setup in the very beginning. And then we can find the volume. So we're going to divide both sides by 13,600. And then we're going to get a very small value for our volume. 0.00013 meters cubed. All right, so we're almost there. It looks like we're getting pretty close. We do have the volume, but we want to do a little bit of converting. So let's clear a bit more space. Now what we can do is we can take our volume and we want to convert this 1 meter cubed into centimeters cubed. Okay, so we have 100 centimeters. And then once it gets cubed, it's basically 100 multiplied by itself 3 times. So which is actually going to give us 1,000,000. So let's go ahead and actually cross this out and we'll call it 1,000,000. Okay, so that's sort of tricky when you're doing some converting with units that are representing the volume, because everything gets cubed. The 1 cube doesn't really matter because 1 multiplied by itself 3 times is going to be 1 anyways, but 100 multiplied by itself 3 times is going to give us 6 zeros, which makes 1,000,000. So 0.00013 times 1,000,000 gives us 13 centimeters cubed. And 1 centimeter cubed is actually a milliliter. And that takes us to our final solution. We have 13 milliliters of mercury that need to be added into our hollow cylinder, and that's going to completely submerge it. So I hope all those steps were helpful in helping you learn about buoyant forces, how to use the force of gravity, and apply a bunch of different skills in order to find the volume of mercury. Thank you for watching and listening.